Hello everybody, and welcome to our lesson on residual plots today. This is part A, though should be part B coming up as well. First of all, we talked about residuals. We know they're the distance away from the predicted value that the actual value is, okay? So the residual is the vertical distance from the predicted value on the line to the actual value. A positive residual indicates that the actual point's above the least squares regression line. Negative indicates it's below. And just to mention also that whenever I talk about a line or they ask you about a line or any kind of line in a question, there's only one line we do. It's the least squares regression line. They might call it the line of best fit. There's different names like terminology, but it's always the least squares regression line we're talking about here. Okay? Okay, to calculate the residual value, it's the actual value minus the predicted value. And as I mentioned in class before, there's a mnemonic RAP, Mr. RAP, but however you want to remember that. But RAP helps me remember that. I have a hard time remembering if it's the actual minus predicted or predicted minus the actual. I'd have to do the math and make sure it's negative or positive as it should be. Okay, so this helps me memorize that. It's one of the things that I think is very valuable to know in the AP exam. Residual equals actual minus predicted. That's our acronym there for it. That'll keep it straight in your mind as we go through the year. Okay, the residual plot, okay? Now when we go to evaluate, we haven't talked about this very much yet, but when we go to do a scatter plot, and then before we apply a least squares regression line to that, in other words, before we perform linear regression, do anything with that, we need to determine if it's a linear relationship, okay? So we're gonna look at the scatter plot and see if it looks linear. We're gonna check the correlation coefficient. Hopefully it's a strong value indicating we have lines that are fairly close to we have data points that are fairly close to the least squares regression line, okay? But one of the main things we're gonna check is the residual plot, and we haven't done that yet, okay? That's used to further validate that a linear model is appropriate. It amplifies any nonlinear pattern. We are looking for a random pattern to indicate that a linear model is appropriate. Okay, so if I were to have a little curve in my data, okay, when I look at the residual plot, a big curve will show up. It'll show me that I really have a curved relationship, not a linear relationship. And then I would say, no, it's not appropriate to apply linear regression to this problem. Okay, so it's sort of like looking at it with a magnifying glass, okay? And I tell my students every year, truthfully, if I see a slight curve, I already know it's going to show up as a big curve in the residual plot. Okay, they're going to expect you to check that residual plot every time before you do any kind of least squares regression work. Okay, so we'll be looking at how to do that. But again, it amplifies any pattern. Any pattern that you would see would be a nonlinear pattern, okay? So we're looking for a random scatter of just stuff on there. Some are up or some are below. There's no defined shape. And typically what we're looking for is like a curve. If we see a curve, we know it's not appropriate to use linear regression. That's the most common one you'll see there, okay? There's different ones. There's a fanning pattern. There's different things like that. But the curve is the typical one that you see, and if that's the case, then we're going to have to do something which we'll learn later, which we'll try to transform the data, see if we can straighten that line. But we don't want to apply a linear model to something when I know it has a curved relationship. Okay, so again, what are we looking for? If I'm trying to apply linear regression, the good for me, what I'm looking for there is a random scatter. It's a blob of dots going across the residual plot. Okay? Okay, is linear regression appropriate? Okay, well, conditions to ensure it's appropriate. The scatter plot must appear linear. Right away, if you have a scatter plot and you see a giant curve, you don't need to waste your time going forward. Okay, it's not a linear relationship. Okay, all right. Second, if we have a good, strong relationship, we're going to make predictors predictions with, then we would like our actual values to be very close to the line. That way, when we predict values on the line, they'll be close to the real values. So we're looking for a strong linear relationship or high value of correlation. Should be in the strong category. And again, positive or negative, that just means it's going uphill or downhill, indicates nothing of the strength. So we're looking for a strong, either positive or negative, correlation. Okay, and those are two items that you have so far. You can visually check those right now, but the new one coming is the residual plot. Okay, and this is probably, I mean, this is really the most important one, I'd say. But on the AP exam, when you're working, they're going to give you something that's reasonable. Your residual plot is probably the strongest indicator of a linear relationship or a non-linear, either one, a linear or not linear relationship, okay? So it doesn't sound like it's possible here, but you can have strong positive correlation or negative correlation indicating like a straight line, right? But still, the scatter plot will show you that curve, and then we would know it's really underlying, it's really a curve pattern. Okay, we'll look at some examples of that in class, okay? So you want to make sure that residual plot always is solid, just showing a random scatter, and then you're good to go ahead with your least squares regression line and calculations and such. Okay, this is a scatter plot, okay, and I can see, it looks pretty good, like my dots are pretty close to my line, okay, but I can see that it looks like it's got a little bit of a curve, okay, and you'll watch when I put it over on my residual plot, how that curve is amplified and you can really see it, okay? So like I said, I'm not really surprised, but it demonstrates that it would or would not be a linear relationship there, okay? So this is something, I don't have anything on the X or Y axis. This is my explanatory. This is my response variable on the Y always. Okay, we plotted our data points. We found our least squared regression line, and there's our picture right there. Okay, so what we're gonna do is manually calculate the residual plot right here. Okay, your x-axis, would be whatever it is over here. So what we're doing really is we're just doing another scatter plot, and you're going to graph it the same way in your calculator. We're going to graph it the same way we calculate a scatter plot. We're going to choose a scatter plot, but instead of our y-axis being list 2 like it normally is, after we've calculated the least squares regression line, the calculator has calculated all the residuals, it has them loaded, and we're going to be able to load that file in for like the y-axis. So it'll say your y list, and right now normally it would say list 2, and we're going to change that to the residuals, and it's going to plot our regular x's, and our vertical will be the residual, how far away we are from the line. Okay, we'll do that in our calculator. We're going to do it manually right now. Okay, here's my first point. When x is 2, the residual is a positive 1 because it's up above 1. And notice my residual graph, okay, they'll always look like this, the vertical of the 0 being in the middle because my residual, my least squares regression line, remember it's situated such that the residuals are the smallest possible, and half of the residual amount is plus and half below. That line's kind of like the average going right through there. Okay, so half of them will be like, not half of the number, but half of the values will be up here, and half of the values will be down there. If I add those together, they equal 0. Okay, all right, here we go. So when x is 2, the residual is positive 1. Okay, so let's get up there. Oh, there's a value right there. That's one of my dots on my residual. When x is 3, the residual looks like 0. It's right on the money. When x is 4, let's call that negative 0.5. Notice my scale is very large here, as it will be on yours. It's going to amplify that vertical direction. Okay, we're at 5 now. When x is 5, it looks like negative 0.5. It's half below as well. Okay? When x is 6, it's down at negative 1, which is way down here. When x is 7, okay, we have 2. We have 1 that's plus a half. 1/2. And we have 1 that is down 1 at negative 1. Okay, it's okay. We had 2 different 0.7 something and 7 something out. That happened all the time. Okay, at 8, we have a residual of 0. And at 9, we have 1 at plus 1. Okay, and if you see, I look at it now, and other than there's a little bit here, but it looks like I have this type of a pattern going there, okay? And that would be a curved pattern, and linear regression would not be very good in this case. But the main thing I'm worried about here is not that. It's just being able to understand what the residual plot is, okay? So that's a plot of the residuals. For every x, I can find out what the residual is for that point. Oh, negative 0.5. Oh, down here it's negative 1. Oh, at 9, the residual is positive 1. It's 1 above the predicted value. Okay, so that's what a residual plot is right there. This will be part B. So that's it. Thank you for watching that first part. Thank you.